Welcome back to SpaceX Daily, Episode 14. I'm Patrick in Vancouver. Today is June 25th, 2026. Let's get into today's SpaceX developments. Vandenberg's cleared expansion and yesterday's Starlink launch raise Falcon reuse counts, while Starship hardware moves toward orbital compute tests. The Starlink 17-45 mission lifted off from Space Launch Complex 4E at Vandenberg Space Force Base at 8:30 p.m. Pacific Daylight Time. The flight added another mission to the active booster fleet and continues the West Coast cadence that keeps testing turnaround intervals. This launch fits the ongoing Falcon reuse arc by adding another flight to the active booster fleet and testing turnaround intervals that remain the program's central open question. Listeners should watch the next Vandenberg pad cycle for any further compression of those intervals. Regulators approved further development at the Vandenberg site, allowing SpaceX to increase launch infrastructure. The decision directly supports higher annual launch rates by expanding pad and support capacity. It moves the Falcon cadence open question forward by removing one physical constraint on flight frequency. Next milestones to track are construction timelines and any updated flight rate targets. SpaceX has assigned a formal name to the planned constellation of AI-focused orbital data center satellites. The designation marks a concrete step from concept to program-level planning. It ties directly into the Starship payload and refueling milestones that remain the key open questions for large mass orbital deployment. Observers will watch for hardware integration timelines once Starship reaches sustained orbital operations. Starship's payload bay and refueling architecture are cited as the enabling hardware for placing AI compute nodes in orbit. The article links the vehicle's mass-to-orbit performance directly to the feasibility of large-scale orbital data center concepts. This development sits on the Starship reuse and refueling timeline that the program is still proving. The next visible marker remains a successful orbital refueling demonstration. Investor Mark Andreessen stated that Starship's capacity removes the primary mass barrier to orbital AI infrastructure. The comment frames the vehicle's design choices around rapid reusability and high payload as the decisive factors. It connects to the same open questions of booster catch and refueling cadence that determine when such missions become routine. Watch for any updated manifest entries that test those capabilities with compute hardware. An unnamed SpaceX investor forecasts that orbital AI data centers will appear in the near term. The prediction rests on Starship's demonstrated and projected payload growth. It aligns with the same refueling and reuse milestones that determine when such hardware can be placed and maintained. Observers will monitor Starship flight test results for any payload bay configurations suited to compute modules. The analysis highlights Starship's combination of high mass to orbit and rapid reusability as the enabling factors for placing AI hardware beyond terrestrial power limits. It frames the vehicle's design trades around propellant transfer and booster recovery as the decisive engineering choices. Those same trades remain the active open questions in the current flight test campaign. Any upcoming test that demonstrates refueling will directly test the assumptions in the analysis. SpaceX AI has pledged to restart work on the water treatment facility supporting the Memphis Compute Campus. The commitment addresses a key infrastructure element required for sustained high-density GPU operations. It forms part of the broader XAI compute buildout that relies on both terrestrial and, eventually, orbital capacity. Next steps include construction milestones and any power delivery updates tied to the same site. Observers on X noted that the June 24th Vandenberg launch used a previously flown booster whose flight history now exceeds 20 missions, though exact serial numbers remain unconfirmed in public tracking data. Separate posts highlighted fresh renderings of proposed orbital compute satellite bus designs that appear sized for Starship's payload fairing. Community members also discussed the Memphis water treatment restart as evidence that XAI terrestrial buildout continues in parallel with orbital concepts. Worth keeping an eye on, key bank analysts flagged execution risk around Starship's ability to meet the aggressive timelines implied by orbital AI data center plans. citing unproven refueling rates and booster recovery reliability at the needed cadence. The note points out that any shortfall in those two areas would delay revenue-generating compute capacity. Resolution hinges on the next series of flight tests demonstrating sustained refueling and catch operations. On the AI front, SpaceX has formally named its planned orbital AI data center constellation, moving the concept from internal study to a tracked program. The naming follows investor commentary that Starship's payload and refueling architecture now make orbital placement feasible within the current development timeline. Its AI separately committed to resuming construction of the Memphis water treatment plant that supports the terrestrial Colossus campus, keeping ground-based GPU capacity on schedule while orbital options mature. From an engineering standpoint, the decision to place AI inference hardware in orbit begins with a simple power and thermal constraint. Terrestrial data centers must reject heat into air or water that already carries the load of the electric grid. In orbit, the same silicon can radiate directly to space at roughly 200 to 300 Kelvin, cutting the energy cost of cooling to near zero once the hardware is on station. Starship's 100-plus ton payload bay and planned orbital refueling therefore collapse the idiot index of lifting the entire stack by replacing dozens of smaller launches with a handful of fully reusable vehicles whose propellant is the dominant consumable rather than the structure itself. The remaining variable is the refueling count per mission. Each additional transfer reduces the effective cost per delivered kilowatt of compute by amortizing the booster and tanker flights across more hardware mass. Once that loop closes, the marginal cost of adding another orbital node approaches the cost of the silicon and solar arrays alone. And a quick market note, SPCX is at $154.54, up 0.4%. Before we go, the next Starship flight test remains the clearest near-term signal for both reuse and orbital compute timelines. That's your SpaceX news for today. SPCX is trading at $154.54, up 0.4%. If the show saves you time, a rating or review on Apple Podcasts or Spotify genuinely helps new listeners find it. I'm Patrick in Vancouver. Thanks for listening. See you tomorrow. And before you go, this show is part of the Neru Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen, OmniView, a balanced daily world news briefing that takes every side seriously. Find every show free at nordih-ra-network.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.